This topic is about continuous and discontinuous functions, and the examples are about piecewise functions. So, example 1, let f of x equal x plus 2 if x is strictly less than 1, and f of x is equal negative 2x plus 4 if x is bigger or equal than 1. And the question is f continuous at x equal 1, not 2. So how do we check that? There are three things we need to check. First, we need to check if f of 1 is defined. And here means we need to check if f of 1 is equal to a number. F of 1 is what? We're going to use this function because x is bigger or equal than 1. So all we need to do is plug it in. So minus 2 times 1 plus 4. Negative 2 plus 4 is equal to, so it is defined. For 2, we need to check if a limit of f of x as x approach 1 exists. How do we check that? We need to do right and left limit. So limit of f of x as x approach 1 from the right side is equal, because it's a piecewise function, it doesn't have the same value on the left or on the right of 1. So we need to do right and left. So here, since x approach 1 from the right side, we need to use this function again. So limit of minus 2x plus 4 as x approach 1 from the right side. Now all we need to do is plug it in. Minus 2 times 1 plus 4, which is 2. Now what about the left? A limit of f of x as x approach 1 from the left side. And this time we're going to use this function because we're approaching x from the left side. So it's a limit of x plus 2 as x approach 1 from the left side. Now if we plug it in, we get 1 plus 2, which is 3. Now we can see on the right we got 2, on the left we got 3, on the left of 1. So limit does not exist. So therefore, a limit of f of x as x approach 1 does not exist. So therefore, f is discontinuous at x equal 1. Now you can tell, let's graph it. See, when x, so on the left of 1, here is 1. On the left of 1, we need to graph y equal x plus 2. So let's pick any two easy points. When x is equal 0, it's a line. When x is equal 0, y equal 2. So here's the point, 0, 2. When x equal 1, even though 1 is not defined there, we can use it and just exclude that point. When x is equal 1, y is equal what? 1 plus 2 is 3. So it's right here, but I'm not using that point because x is not defined there. Right? So this is the line on the left of x equal 1. Now, on the right of 1, when x is bigger or equal than 1, I need to graph y equal minus 2x plus 4. I'm going to use any 2 points. So let's use x equal 1. When x is equal 1, y is equal minus 2 times 1 plus 4. So y is equal 2. So the first point is 1, 2, which is right here. And then when x equal 2, y equal minus 2 times 2 plus 4. So y equals 0. I got this point, so this is the graph. So you can tell it's not continuous at x equal 1 because there is a break at x equal 1. Right? This is the break. And that's it for this example. Next example, we're going to show a piecewise function where it's continuous.